Yeah, so your 2 minus 2i, sorry. Look at this question. We want to find the argument of 2 minus 2i. We use these questions to understand the difference between argument and principal arguments, okay? Now, 2 minus 2i is actually, we find the argument which is theta, which we say is tan inverse of y over x. So in this case here is tan inverse of 2 over 2, which will give us tan inverse of 1, and tan inverse of 1 is equal to 45 degrees, okay? But 45 degrees is not the answer. The reason is that if you notice here, your real part is positive, but your imaginary part is negative. So if we draw our quadrat, in our quadrat we have 0, we have 90, we have 180, and we have 270, then here 360, okay? Now positive x and negative y, this is positive x here, and this is negative y, okay? You can see where it lies. So from here, from this center, that means this particular complex number lies here. Now if I want to find the argument, I must go clockwise. That means from the positive value of x, that's argument. Okay, so from here now, coming here, from here to here. Now, according to what we calculated, this 45 degrees is actually here, from here to here, 45 degrees, okay? So, but the argument now is from the right to this point. Wow, that's quite a long journey. So, it means that our argument theta in the real sense is equal to 360 minus 45 degrees. Remember, going clockwise from the positive x direction. Okay, so it's 360 minus 45 degrees, which is equal to 315 degrees. You know, you can convert that to radians to get the answer. Now, but for principal argument, I can go clockwise or anti-clockwise. Like, I can't say 315 is principal argument, no, because 315 is not between minus 180 degrees and 180 degrees, okay? So, what I would do is that, remember, principal argument, you can count either clockwise or anti-clockwise as long as the angle is between minus 180 degrees and 180 degrees. So it means that in this case now, the best way is to count anti-clockwise for principal argument. So that means my principal argument, which is ARGZ now, will be equal to minus 45 degrees. That's the answer. Okay, so whether I use minus 45 degrees or I use 315 degrees, it's still the same thing. It will still give me, I will still arrive at the same answer. So that is the difference. Now, like we said earlier, argument does not have, this minus 45 degrees can also be seen as argument. 315 degrees can also be seen as argument, you know, and many other values that we can cook up, you know, but particularly principal argument is this, minus 45 degrees. Okay, so let's see the next question. Now we are given this minus root 3 plus I. Now if we find the argument is supposed to be tan inverse, theta is supposed to be tan inverse of 1. The imaginary part is 1, the real part is root 3. Leave the negative sign for now. So and tan inverse of 1 over root 3 should give us 30 degrees. Now if I have my quadrant, if you notice, this is negative x-axis and positive y-axis. So negative x-axis, this is it. Positive y-axis, this is it. So this is where, you know, we have that complex number. And to find argument, you must go from here, from the positive x-axis. So from here to here. Okay? And that is what we have. Remember, this 30 degrees is always the angle the complex number makes with the horizontal. Remember, your theta is the angle the complex number makes with the horizontal. So that means that 30 degrees, this is where the 30 degrees is. So if I want to find here to here, that means from the positive x-axis to here, angle on a straight line is 180. It means that my ARGZ, argument of z, is equal to 180 minus 30, which is equal to 150. Remember, the argument is from the positive x-axis to the complex numbers. So your theta is 30 degrees, which is what we found here. We have to subtract from 180 to get the argument. Now, one of the principal arguments, in this case here, since the argument is 150, principal argument is also 150. It cannot change. as long as that value there is between minus 180 degrees and 180 degrees. So I can just simply write 150 degrees. I will follow clockwise, because following anti-clockwise will give us a very I'll follow anti-clockwise, because following clockwise will give us a very large number which is greater than 180 degrees. Okay, so we see the next question. Minus 8i. Now as we are given minus 8i here, we can also write that 0 minus 8i. Now theta now will be equal to tan inverse of 8 over 0, and that's indeterminate, and tan inverse of something that is indeterminate is 90 degrees. Okay, that's because tan 90 is indeterminate, so tan inverse of what is indeterminate is 90 degrees. Okay, so if we take our quadrant here, my real part is positive, your x is positive. Okay, but not really about x, because x is 0, but about y is negative, so that means here, meaning that this is what we want. The 90 degrees, the angle it makes to the horizontal, which is this now, is 90 degrees. So what is our argument? Our argument will be from the positive x-axis going anti-clockwise till we get to that complex number. And that is, this is 90 degrees, this is another 90 degrees, making it 180, this is another 90 degrees, making it 270. So my argument of z is equal to 270 degrees. Now, but the principal argument, which is ARGZ, I can't take 270, is beyond minus 180 and 180, so I count clockwise rather, and that clockwise direction is just 90 degrees. So that's my answer. So whether I take 270 or I take 90, it's correct. Okay, I want to believe that those examples are enough. Do this now. Look at the questions and get back to me very fast. Thank you very much.